Hello everyone, and welcome back to Data Engineering with Subhadip. Today, we're diving into some powerful techniques to optimize your Google Cloud Dataflow pipelines. We'll explore how to supercharge your jobs using autoscaling and a concept known as fusion breaking. In this session, we will start by understanding how Dataflow's worker autoscaling helps manage resources efficiently. Then, we'll demystify the concept of pipeline fusion, a key optimization feature. After that, we'll learn why you might need to break this fusion and how to do it. Finally, we'll touch upon using the Dataflow UI to monitor and profile your jobs. First up, let's talk about autoscaling. At its core, Dataflow autoscaling is a feature that automatically adjusts the number of virtual machine workers for your job. It scales up when there's more data to process and scales down during lulls. This is crucial for balancing performance with cost, ensuring you have enough power when you need it without overpaying for idle resources. While autoscaling is automatic, you can provide guardrails. Using pipeline options, you can set the maximum number of workers a job can scale to with max num workers. For streaming jobs, you can also set the initial number of workers at launch. This gives you control over both performance and budget. Now let's move to a fascinating optimization feature: pipeline fusion. When you submit your job, the Dataflow runner doesn't execute your code exactly as you wrote it. Instead, it analyzes the pipeline and fuses, or combines, multiple sequential steps into a single, highly optimized stage. This is a huge performance win because it minimizes the overhead of moving data between steps. To visualize this, imagine you have a pipeline that reads data, performs a map operation, and then filters it. Logically, these are three distinct steps. But Dataflow's optimizer sees that these can be done together. It fuses them into a single stage, where each element is read, mapped, and filtered in one go on the same worker before moving to the next stage. So if fusion is so great, what's the problem? The issue arises when one of the steps inside a fuse stage is a significant bottleneck. For instance, a transform that makes a slow network call, or performs a very heavy computation. Since the entire stage is a single unit of work, this one slow step can hold up everything, and Dataflow can't parallelize the subsequent steps across more workers. This is where fusion breaking comes in. We can intentionally insert a barrier to prevent fusion. The most common way to do this is by adding a beam.reshuffle transform. A reshuffle forces Dataflow to materialize the data, write it out, and then read it back in, effectively shuffling it across the worker pool. This creates a clean break, allowing the next stage to be fully parallelized. So let's see the impact. Before the break, the map, the slow operation, and the filter are all stuck together in one stage. The slow op creates a bottleneck. After we add a reshuffle, the map runs as its own stage. Then the data is shuffled. Now the slow operation can run as a separate stage, and Dataflow can scale it out across many workers to process the data in parallel, dramatically improving throughput. How do you know when to do this? The key is monitoring. The Google Cloud Dataflow UI is your best friend here. You can visually inspect your pipeline's execution graph. Look for stages with a very high wall time. This indicates that the stage is taking a long time to complete. If you see a fused stage with high wall time, that's a prime candidate for inserting a fusion break before the slow part. So to summarize our key takeaways, first, let Dataflow's autoscaling do the heavy lifting, but always set guardrails like max workers for cost control. Second, understand that fusion is generally good and improves performance. Third, when you identify a bottleneck within a fuse stage, use reshuffle to break the fusion and improve parallelism. And finally, none of this is possible without good monitoring, so make the Dataflow UI your first stop for debugging performance. And that's a wrap on optimizing Dataflow pipelines with autoscaling and fusion breaks. I hope this session gave you some valuable insights. If you found this video helpful, please hit the like button, share it with your colleagues, and don't forget to subscribe for more data engineering content. Thank you for watching, and I'll see you in the next one.